Hello dear friends, welcome again to my YouTube channel Geotechnical Engineering Consultancy Tips. Today I will be telling you all about how to find the ultimate load capacity of world class in-situ piles based on standard penetration test values, the data, the SPT values which you obtain while doing the actual geotechnical investigation work at the site, especially for cohesionless soils. One can even find these pile lengths for any given diameter of pile if decided in advance, and as well if your safe capacity of the board pile has been decided the desired values, then you can find the length of the pile by using these formulas, Meyerhof formulas specified in this particular code, which I will be discussing with you all about by reverse calculations. The Indian Standard Code referred to for explaining these things is Indian Standard Code IS 2911 Part 1 Section 2 2010, that is the Design and Construction of Pile Foundations Code of Practice Part 1 Concrete Piles Section 2 Board Cast In Situ Concrete Piles Second Revision. Now, the correlation suggested by Meyerhof using standard penetration resistance and is insaturated cohesionless soils to estimate the ultimate load capacity of board pile is given below. The clause B 4.1 of this IS 2911 Part 1 Section 2 2010 states that the ultimate load capacity of pile QU in kilonewton is given as QU is equal to 13 N L by B AP plus N in red AS divided by 0.50, where this first term 13 N L by B AP gives you the end bearing component, the end bearing resistance of the pile, and this and demarcated in red with AS upon 0.50 gives you the frictional resistance of the pile, where N is the average N value at pile tip, L is the length of penetration of pile in the bearing strata in meter, that is the length of the pile below the cutoff level, B is the diameter of the pile in meter, AP is the cross sectional area of pile tip in meter square, N is N in red is average N value along the pile shaft, and AS is the surface area of pile shaft in meter square. Now just to explain you all, I have prepared a figure on the right hand side of this slide where I have shown you the N values being joined by this line along the depth starting from 0 meter till 10-meter depth explored below ground level, and these N values are found to range from 5 to say around 20 to 23, and the water table found at the site was around 2 meter below natural ground level. QU is just shown for depiction purpose, that it symbolizes and indicates your ultimate load capacity of pile. 1.30 meter is the cutoff level taken in this very calculations, and 8.7 meter is the length of the pile below the cutoff level. So now the only thing to understand is that the N, this N at pile tip is to be taken as this value where you are resting your pile, and N in red, which is the average N value along the pile shaft, is the average of the pile is the average of the N values standard penetration test values being obtained right from below the cutoff level till the what you say just the N value just before your pile tip. The important point to note here is that the end bearing resistance cannot at all exceed 130 NAP as prescribed by the code. Now coming on to my next slide. Everything remains the same except that the correlation suggested by Meyerhof using standard penetration resistance and value in non-plastic silt of very fine sandy soil to estimate the ultimate load capacity of board pile is given below as per clause B-4.2 of IS 2911 part 1 section 2 2010, which indicates that this equation now will be QU is equal to 10 N L upon B into AP plus N in red, that is the average N value of along the pile shaft, AS divided by 0.60. All other terms and denotions remain the same as explained to you in my earlier slide, where N is the average N value at pile tip, L is the length of the pile, B is the diameter of the pile, AP is the cross-sectional area of the pile tip, N in red is the average N value along the pile shaft, and AS is the surface area of pile shaft, with the condition that the end bearing component in this case also will not be allowed to exceed 130 NAP. Now, How do we calculate the safe pile capacity? As per clause B5 of IS 2911 part 1 section 2 2010, the factor of safety to be taken is defined as 2.5, and when we apply this factor of safety, that is divide this ultimate load capacity by 2.5, we get the safe pile capacity as defined by this code, Indian Standard Code IS 2911 Part 1 Section 2 2010. Now, one can even find the length of the pile if your safe pile capacity of board pile with requisite diameter of pile is already pre-decided, as all other data, including standard penetration test values, is available by using these formulas. You can hence therefore get these values as well. Hope you would have loved this lecture of mine and must have got a fair bit idea of how can we calculate pile capacities based on n values obtained, standard pressure test SPT values obtained at the site using this Meyerhof equation, which has been specified in this very code as discussed with you. Namaskar, thank you for your patient hearing. Keep on subscribing to my YouTube channel Geotechnical Engineering Consultancy. Thank you very much.